Okay, so that was also the Leff trio, by the way. And then there's the bass drum. Now this one I recorded off the internet. There is a pedal on the other side of the drum where the drummer sits, and it sounds something like this. And then there's a hi-hat, which are two cymbals facing each other that are controllable by a pedal. That pedal is down over here. I think I missed one, but I can't start again because it'll go back to the beginning of the slide. That's the crash. And then the last one is the ride cymbal. Okay, so you get an idea of the different parts of the kit. And I guess one thing I wanted to emphasize that the drummer uses all four limbs. Okay, I didn't know this. I started playing drums when I was 60, when I got a kit as a surprise for my family. I'd never played before. I had no idea the drummer used all four limbs. I thought it was only hands. I've come a long way, baby. All right, now let's talk a little bit about the physics. Everybody is familiar with vibrations of a string and standing waves on a string. The thing I want to point out is that the speed of propagation depends on a tension, which is in newtons, and a linear mass density, kilograms per meter. And there's a fundamental, and there are harmonics. And there are nodal points which sit like this. There they are, there's some of them. If you look, go to 2 dimensions to a drum head and take a small section of it, and if you look at one side, let's say, of that section and ask what's the force pulling on it by the rest of the membrane, it depends upon the length of this section, actually. And this T sub S is a surface tension, which has the units newtons per meter. Okay, it's a force per unit length. And knowing that, then it turns out that the speed of the propagation on the drum head is T sub S over sigma. It's the same basic expression as this one, except that here you have a surface tension, and sigma is the surface mass density, kilograms per meter squared. For drums, the frequencies generally, the kettle drum being an exception, the frequencies are not harmonic. And instead of getting nodal points, you get nodal lines, and that's what makes it very interesting, actually. All right, so if we go into a little more detail, and I'm not going to do a lot of math here, but I'll show a couple of equations, or several equations. The key elements of a circular membrane are simply the 2 things I talked about already, the surface tension and the surface mass density, and also the radius. What we're interested in is the displacement U, which is perpendicular to the plane of the membrane, and we are interested in it as a function of R, the angle around the drum, theta, and the time. Okay, so to look for normal modes, you solve the 2-dimensional wave equation, which I certainly won't talk about here, but I just want to tell you that the solution is a product of a function of the radius. That's a Bessel function, J sub m, Bessel function of the first kind. And it involves the radius here. It also involves something that is a wavelength for the Mn mode. And I'll talk about why there are 2 subscripts there. And then this is an ordinary cosine, or generally this should be a linear combination of sine and cosine. And then for the time, also one gets a cosine, or generally a linear combination of sine and cosine. The Bessel functions, in case you don't remember, are oscillatory. So they're sort of, if you look at them after the beginning of J0, J0 starts off well away from the origin, but if you get away from it, they sort of resemble sines and cosines. So they're rather similar in that respect. they're wiggly and they're involved in waves, okay, and in standing waves. And so it's good to understand that. All right, now, there's a boundary condition on a drum, namely the membrane is fixed around the rim, all right? This is that boundary condition here, and that gives rise to looking at the roots of the Bessel function, which you can see are here, and they're involved for J0, J1, J2, and actually there are an infinite number of those things. All right, what comes out is that there's a frequency for each M and N, and maybe I should just say the M is the number of nodal diameters. It's the M that's up here in the cosine, and the N is the number of nodal